Hello everyone, welcome to lesson 2-4, solve equations with variables on each side. We will continue to address the question, what is equivalence? Let's start by looking at a real-world example. Cell phones. A wireless company offers two cell phone plans. Plan A charges $24.95 per month plus 10 cents per minute for calls. Plan B charges $19.95 per month plus 20 cents per minute. Use the questions to find when the two plans cost the same. So just to review those numbers, we have $24.95 per month as the flat rate plus 10 cents for every minute on the calls. And we have $19.95, which is a lower monthly bill or flat rate, but a higher per minute charge, double than this one. So the equations would be $24.95 plus 10 cents per minute. Every time there's a minute, you add 10 cents to it. So 10 cents times M. And this one would be $19.95 plus 20 cents times minutes. You see, as you see here. Plan A, Plan B. You can pause and take a look at this table. Here we have 10 minutes, 20 minutes, 30 minutes, and so on. And we're just going to use this to replace the variable M. You can see. So over here, it would be $1. Over here, it would make it $2, $3, and so on. Okay, let's replace the variables and solve for each line. Over here, if I replace M with 10, I will have 10 cents times 10 is $1. And it's $1 plus $24.95 would make it $25.95. And if we continue with this pattern, right? If I'm doubling the number, here's 10 dimes, right? Because this is 10 cents, a dime. Here's 10 dimes. Here's 20 dimes. 20 dimes is $2. So all I'm going to do is now add another dollar. Here at 20 dimes, it's $2. So I add $2 to the $24.95. Here I add $3 to the $24.95. Here I add $4, $5, $6, and $7. So I'm going to go ahead and do that and just add that amount of dollars to it. If you have any questions, please remind me in class to go over this again, or simply just watch the video again or pause and see if you can analyze the content. 10 cents times 10 is $1, so we add $1 to the amount. 10 cents times 20 is $2, so we add $2 to the amount. I hope you understand that. Every 10 cents is $1. So you can see that because we're increasing by 10 cents each time, or by 10 minutes, you can see that it's increasing by $1 each time. Okay, let's look at Plan B. Now we have $19.95 plus, and this is double, 20 cents per minute. So 20 cents times 10 is $2. $2. So we're going to add $2 to this. It's not $20.95, it's $21.95, our first one. And it's going to jump up by $2 each time, because it's 20 times 10 is $2. 20 cents times 10 minutes. And the pattern continues. Every 10 minutes is going to be an additional $2 on this side. Every additional 10 minutes will be an additional $2. So you can see that it's jumping up by $2 each time. 21, 23, 25, 27, 29, 31, 33. You can see that at 70 minutes, it's $31.95 here. But at 60 minutes, it's $31.95 here. So Plan B, even though it seems cheaper up front, it's actually more expensive because you only get 60 minutes for $31.95 here, but here you get 70 minutes for $31.95. For what values does Plan A cost less? So what they're asking us is, at what point does Plan A remain cheaper? Here it's cheaper for 10 minutes, it's cheaper for 20 minutes, it's cheaper for 30 minutes. You see that? 25 here, 27 here. It's cheaper for 40 minutes. It's the same for 50 minutes. They both cost the same for 50 minutes, But then plan A starts to get more expensive. You see that? It goes up by another $1, and then over here it's $2 more. So for what values does plan A cost less? For less than 50 minutes. So the question actually is, for what values does plan A cost less? So this is plan A. Plan A starts to cost less after 50 minutes. So for values greater than 50 minutes. For what values does plan B cost less? Well, plan B costs less when it's less than 50 minutes. For values less than 50 minutes. For what values do both plans cost the same? Right here at 50 minutes, don't they? They both cost exactly the same. So at 50 minutes. Let's read through our first key concept of this lesson. Equations with variables on each side. Some equations, like a plus d plus 4d equals 5d, have variables on each side of the equal sign. To solve, use the properties of equality to write an equivalent equation with the variables on one side of the equal sign. Then solve the equation. For example, here we're going to use the property of equality of subtraction, and we have 8 plus 4d equals 5d. Let's subtract the 4d from both sides. And the reason is because we're trying to isolate the d on one side. If we subtract 4d from this side, we're simply left with the 8. And if we subtract the 4d from this side, we're simply left with just 1d, because there's 5 of those d's. Now we're just left with the 1 of them. So 8 equals d. Okay, or d is 8. To check your solution, replace d with 8 on the original equation. So we're going to have 4 times 8 is 32, and 5 times 8 is 40. 8 plus 32 is 40. 40 is 40. If I went too fast for you in this part, please pause the video and read through all the steps. Pause now. Okay, continuing on. Here's example 2. Solve 6n minus 1 equals 4n minus 5. Again, let's subtract the n's out. I'm going to leave the n's on the side that it has the greater value. So I'm going to take 4n and subtract it out on both sides. So this is gone, and over here I'm only down to 2n's. So now it's 2n minus 1, and now you can see it's just a two-step operation with a variable on one side of the equation. Let's get rid of the negative 1, so plus 1 on this side makes it negative 4. 2n equals negative 4, divide both by 2, and n equals negative 2. Let's check. When you replace negative 2 on both sides, here I get negative 12, minus 1 is negative 13. Over here, 4 times negative 2 is negative 8, and negative 8 and negative 5 is negative 13. There we go. Okay, if you feel confident, please go ahead and try A and B. Pause the video now, and then check to see how you did. Pause now. Okay, I hope you paused the video. Let's try A together here. Now what I want to do is I want to try to isolate one of these two A's. So I will take this 5 over here and bring it over 5a and bring it over to this side. Okay, or I can do the subtraction property of equality, where I'm going to subtract it from both sides. But I like to isolate and invert. So I will bring this over, and now it becomes minus 5, negative 5, a, and now I have 3a left. And 3a equals 21. Okay, now we can go ahead and divide both sides by 3 to isolate the a. Those 3's are gone, so I have a left, and 21 divided by 3 equals 7. So a is 7. And you can always check by replacing it. So 8 times 7 over here is 56. And 5 times, so on this side we have 56. I'll write it down so that we don't forget 56. And on the other side we have 5 times 7 is 35, plus 21 is 56. So they are equal. Okay, let's try B. Again, we want to isolate one of these two x's. I will keep the x, the one that has, I will try to isolate the side that has the most number of x's. So I will bring this 3x, which is positive 3x, over to this side, and it becomes minus 3x. And now I have 5x. 5x plus 23 equals negative 7, right? Now it looks like I only have one variable, so I can go ahead and do the reverse order of operation, where now I'm going to try to isolate this x. So I will move this positive 23 over to this side, and it becomes minus 23. So minus 23 on this side altogether becomes negative 30, right? Negative 30 equals 5x. Now I divide both sides by 5, so the 5's are gone here, and I'm just left with x. And on the other side, I take negative 30 divided by positive 5 is going to be a negative number, and it's negative 6. Okay? For example 3, let's take a look at a real-world example. Green's gym charges a one-time fee of $50 plus $30 per sessions for a personal trainer. So one-time fee, just to have access to the club, the gym, you're going to pay $50. But then after the $50, you're going to pay $30 for each personal training session. A new fitness center charges a yearly fee of $250 plus $10 for each session with a trainer. For how many sessions is the cost of the two plans the same? So again, like we did in the very first example where we created a table, we can go through and figure out when they would be the same. So here we go, the words. Here's the fee of $50 plus $30 per session, and $250 for the year plus $10 a session. So let's represent the number of sessions. So we have $50 plus 30 per session is the same as 250 plus 10 per session. Okay? So at what point will the sessions be the same, the number of sessions? So we go ahead and solve. For this part, boys and girls, I want you to just pause the video and read through it yourself. Read through all the steps, follow all the steps, and make sense of this. Because eventually, you will have a textbook all to yourself, and you will have to do this on your own without a video, and actually comb through and dissect these word problems all on your own. Okay, so pause the video and analyze this. Go ahead. Okay, I hope you paused the video and you are familiar on how we can do this. So let's try question C together. Or you go ahead and pause the video, try it on your own, and then check how I did it. Pause now. Okay, let's try it. The length of the flag is 0.3 foot less than twice its width. If the perimeter is 14.4 feet longer than the width, find the dimensions of the flag. Okay, this question was a bit hard for me to do, and but I figured it out. So we have to create an equation first, an equation from the information that we are being given. And I know so far that I can say the perimeter is 14.4 feet longer than the width. So the perimeter, I can say, is the width plus 14.4, correct? That's my perimeter on this side. And I want to create another equation based on the perimeter from the information that I know. And I do know that the length, okay, the length is 0.3 foot less than twice the width. So if I have, this is only one length, right? So it would have to be this 2 times to have both lengths, correct? So one time it's saying that it's 2 times, right there, it says twice the width. There's twice the width minus 0.3, correct? This is only one length. This is only one of them. So I need 2 of these, right? 2 lengths, because if we actually look at a rectangle, right, our perimeter is the distance around it, all the way around it, And that's here. That's what we have there, right? And over here, what I have is just one length, just this one right here, right? I need this one as well. I need to account for that one as well. So I'm going to multiply that by 2. And now I have both lengths, plus 2 widths, this width and this width. So 2 widths. Now I can say this is also the perimeter. So here I have the perimeter, and here I have the perimeter. Now I'm ready to solve. I will simplify this side first before I actually go ahead and solve. So this side right here, I need to simplify it. So I will use distributive property over here, multiply the 2 times the 2w and the 2 times the 0.3. Okay, so I get 4w, right? 2 times 2w is 4w, and 2 times 0.3 is 0.6 plus 2w, right? And on this side I still have w plus 14.4. Then I can take this right here and I add it up. I'm going to simplify it even further. So I have 4w plus 2w is 6w minus 0.6, correct? And on this side I still have w plus 14.4. Now we have an equation with a variable on both sides. Let's isolate this variable here. So let's bring this one over and subtract it. So we're going to take this w, bring it over here, and it's going to become minus w. So this, on this side of the equation, it becomes 5w minus 0.6. And on this side, it's 14.4. W is gone, right? We took it out of there. Okay, so now I am going to continue to isolate this w. So I'm going to bring this minus 0.6 over to this side and it becomes plus, right? The opposite operation. If it's minus here and goes over to this side, it'll be added now. It'll be inverted. So 14.4 plus 0.6 equals 15. 15 equals 5w, right? Now I'm going to divide both sides by 5, and I get 3. That's my width. So my width is 3. We were able to figure that out. Now that we have the value of the width, we can actually figure out the length now. Remember how we were told that the length was 0.3 less than twice the width? Remember that? Let's take this. This is one length right here, as I explained earlier. This is only one of the lengths. Let's replace that variable. So we have 2 double the width, twice the width, minus 0.3. Let's replace that w. Remember, we have the w right here. We solved it already. So let's replace it. So now it's 2 parentheses 3 minus 0.3, right? Which would be 6 minus 0.3, which makes it 5.7. Sorry, this was L for my length, right? So my width is 3, and I think we were talking about inches. 3 inches, and the length is 5.7 inches. Sorry, I was quick to say inches. I meant to say feet. So therefore, the width is 3 feet, and the length was 5.7 feet. If you found this difficult to do, please go ahead and rewind this video, read over the question again right behind it, and then go over all the steps and see if you can understand why I decided to write it like this. The only thing I could figure out from the information given was the perimeter in both sides. The perimeter was this. They say the perimeter was 14.4 longer than one of the widths, right? So this would be one of the perimeters. And then I used the lengths times 2 plus 2 of the width to also make the other perimeter written differently. And then I solved. I simplified this side, and then I went ahead and solved. Another key concept is equations with rational coefficients. Remember, rational coefficients is, we're talking essentially about fractions, positive and negative. In some equations, the coefficient of the variables are rational numbers. Remember, when working with fractions, you need to have a common denominator before you add or subtract. So sometimes we might have, for example, half a number. This half is a rational number. So this is your rational coefficient. Example 4. For the sake of time, please go ahead, pause the video, and follow all these steps as you see them. Okay, follow all of these steps, read through it. So pause the video now and read through it, and then let's do the practice below. Okay, I hope you went through those. Now let's take a look at these two right here. If you know how to do it, you think you can, go ahead and pause the video and try this now. Pause now. Okay, let's try E. So for E, we have half P plus 7 is the same as 3/4 P plus 9. Let's isolate one of these P's. This one, 3/4 is larger than a half. So let's bring this one over here and subtract it from this one. So when we do that, okay, we have to make it into the same denominator as the previous message just said. So we have to change this to a 4 and the top to a 2. So you notice how if I double the bottom to make it the same denominator, I have to double the top. So now it's going to, I'm taking it from here and bringing it over here, and I'm going to subtract it. And I'm going to subtract 2/4, because it's the same denominator, P, plus 9, right, equals 7. When I do that, I subtract it here, right, I'm going to get 1/4, right, because 3 minus 2 is 1. 1/4 P plus 9 equals 7. Okay, I shouldn't have written the whole thing out yet because I was just solving this part. Now this is the new equation. Okay, I hope you were able to follow that. Now I continue on. Let's get rid of this 9 over here and bring it over to this side. It becomes minus 9, so now it's -2. -2 equals 1/4 of P. Okay, now I have to multiply by the inverse on both sides to get rid of that P. I mean to get rid of that coefficient, right? Let's zoom in so I have more space. And I multiply this side by 4/1 and this side by 4/1. These two cross out. I'm left with just P on this side, and on this side I have negative 8. Okay, so P equals -8. Let's try F. For F, we have some negatives in there that we need to take into account. Okay, I have 5/8, and on this side I have 5/4. So here I have an improper fraction. Okay, so I have more than a whole here and less than a whole here. I have just slightly over half here, because half would be 4/8, so slightly over half, but here I have more than a whole. So this is the one I'm going to bring over here to subtract. You understand? Because this is a half, but this is more than a whole. And I'm going to change this to an 8 so that it can match. And if I change this to an 8, I have to change this to a 10. Double, double, right? So I will do that. I will rewrite it now as 10/8C minus a half equals -3/4 plus 5/8 C. Okay, now I can go ahead and bring this one over to this side, and it becomes minus -5/8 and 5/8 C. Okay, and when I do that, -10 take away -5, it'll be -15. -15/8 C minus a half equals -3/4. Oops, there we go. Okay, now I will bring, I want to isolate the C, remember, so I'm going to take this -1/2, bring it over here, and it's going to become +1/2, right? Over here, bring it over to this side, it becomes +1/2. To make it the same denominator, okay, I have to double it. So I'm going to double that to 4, I'll erase it, it's not in a room. 4, that doubles to 4, and the top has to also double to 2, right? Let me erase that to 2. Now, what do I get? I get negative 1/4. Do you see that? Negative 3/4 plus 2/4, 2/4. It's going to be negative 1/4. So I have negative 1/4 on that side now. Okay? And on this side I have negative 15/8c. Okay. Let's multiply this side by the multiplicative inverse so that we can get rid of this right here. We cross, and cross, and I'm left with c. And on this side, I'm going to also multiply by 8/15, and it's negative, don't forget. Okay? I cross-reference. I have 2 here, I have 1 here. So now I'm going to have negative times negative is a positive. So 1 times 2 is 2, and 1 times 15 is 15. So C equals positive 2/15. Okay, I understand this is not an easy lesson because there's a lot to take into account, but we will work on it in class, and it might take more than one class period for us to cover this material carefully. There's no rush. There's only 5 lessons in this chapter, so we can take our time and make sure that we really understand all the steps. Go ahead and take a look at the guided practice and make sure that you feel comfortable with it. Even if you don't, make sure you come to class with questions. See you then, everyone.